The next item is steganography. Firstly, let's start with a couple of images. Are those two images the same or different? Well, by inspection, it is very difficult to find any differences between those two images. But when we look in detail about what kind of pixel informations they have, those two images are not the same picture. So one on the left is the altered image, and one on the right is the original image. So what is so different about that? Well, one on the left is containing some secret information within the image itself, whereas the original image on the right hand side is just an image. So we'll have a look at the demo quite shortly. The steganography is the art and the science of creating hidden messages which can only be identified by the sender and the receiver, ideally. So basically what we want to do is hide some secret information within another type of information that can be viewed publicly. So here's an example sentence. He encouraged leaving late on Wednesday, only realizing Laurie did. This looks like some typical sentence, a message that can be sent to somebody, but it also has a secret message behind it. So let's have a look by reading only the first letters of each word. When you combine them together, it will generate "Hello World." So we can use different techniques to hide some messages inside other type of data to hide, and this essentially is called steganography. So how does steganography work? Well, here's the flowchart of its work. So firstly, we have a secret message at the top left hand corner, and there's a cover that's going to hide the secret message inside the cover. We have some sort of a stego system encoder that's going to embed our secret message inside the cover. And by optional, we can also use the key, and this is going to protect the secret message even further, because in order to retrieve it, you need to provide a key to decrypt it. Okay. So once this has been encoded, the stego system can provide the decoder as well. The original cover may be needed to retrieve the secret message, but often it is not needed. Okay. So in a very nutshell, the secret message and the cover is an input to the encoder, and the decoder can just retrieve the secret message straight away. And optionally, we can add the key in, and optionally, we can also add the original cover. Okay. So once the encoder encodes the secret message into the cover, this is what we call a steganography object, or simply a stego message. Okay. From the receiver side, the decoder is used to retrieve the secret message. There are a few popular steganography techniques, and those include text-based and media-based. So text-based also divides into different categories. For example, the position of the text, just like we saw in the example before, where we use the first letter of each word to form a secret message. But also the alignments can be used, the alternations of texts, fonts, the size, colors, etc. All those can be used as part of the steganography for the texts. In the media, you can embed the secret message into the images, like the very first questions we had, and also within the videos and audios, etc. And because those media items have very large size, it's very easy to embed some secret message which are quite small, and hence it's very hard to detect in such scenarios. So we'll have a look at an example for both of them. So here's another steganography example that has been used in World War II. So apparently neutrals protest is thoroughly discounted and ignored, blah blah blah. Okay. Can you guess or figure out a trend that how to retrieve the secret message that is embedded in here? The hint is the position of the text. So you can pause the video here and try to figure out what it might be. Have you figured it out? Well, the answer is you can retrieve the secret message embedded by reading the every second letter from each word. And you will retrieve the message Pershing sails from New York on June the 1st. Okay. And I looked up Pershing, and he was a senior army officer from the US. Nevertheless, secret messages can be embedded by the commonly agreed positions, but we can also use the key information to hide secret messages or send secret messages, because sometimes it's very difficult to write fluent sentences by trying to use a fixed location of the letters. So here's another example, which is using the key information from the sentence. So each line we're going to retrieve one letter from each line, and the key use double digits. So you use 06 on the first line, which is meaning you get the sixth letter, so INTHEM. And then the next one is on the position 8, and then 19, and then 13, etc. So when we retrieve all the letter information from this particular text from each line, we have a secret message saying meet at dawn. Okay. So use of the keys can also make the text steganography a little bit more easier. Here's another example. Can you notice anything secret about this? So I will give you a few moments so you can pause the video here, try to figure out what might be hiding. Obviously, it's not the first letters. Maybe you have tried the second letters, but also that's not true. Okay, so maybe we need a key to decode this. Possibly, that's an option. But this particular time, it's not the keys that we're going to use. Now, have a look at the right-hand side, which contains exactly the same information on the left-hand side. But do you notice anything different? If you guessed the unusual white spaces, then you are absolutely right. So you can see that some lines will have an extra white space embedded at the end, some lines do not. And these extra white spaces can be used as a bit information. So if you have an extra white space, it can be encoded as 1. If you do not have an extra space, then it can be encoded as 0. Aha, now we can formulate some binary code which can be used to convert back into the ASCII, and which can be converted back to letters. Okay. So the encoded text is invisible to the human eyes in a typical text editors. However, the file size is going to be altered slightly because we need to also count the white space characters. Is it significant though? Maybe. So let's have a look at our demo. So this is the text white space encoder and decoder. And here I have some original text, which is just a large text file containing lines and lines of texts. Some book. Okay. So first, let us encode. So we have, I'm using Python, encodes.py. So this encoder will ask some details about what kind of files you would like to use. So our input file is the original.txt, and the file that we're going to call for the hiding, we'll call it secret.txt. And now we can embed our secret message here. The pig chased the chicken very quickly. Okay, so this particular one will show you the bits that the secret message is converted to, and now we have encoded hidden message complete. So here now you notice that we have generated the secret.txt file. Okay, so if you know, if we open the secret.txt file again, I will put it down here and open the original text file as well. Okay, so here you can see Muso, he, Sosima, Muso, he, Sosima, te, and I won't argue, buffoon, etc., etc. It's exactly the same text, and you really cannot see any difference until you're trying to identify some white spaces. But obviously, this is going to be quite difficult with this particular editor. So it is likely that it's going to go unnoticed how white spaces are added to embed some secret message. So now let's retrieve our secret message. So this particular system is not using any keys, or you do not require the original mask that has been used. So only the secret text is required to retrieve the message using the decoder. So Python 3 decode secret.txt. Oh, oops, sorry, doesn't take arguments. So what is the hidden file name? Secret.txt. Okay, so the your secret message is the pig chased the chicken very quickly. Okay, so we have been able to retrieve the original message, the secret message that has been hidden into the original text. Okay, and unless you know what decoder to use, it is very difficult to identify what secret message may have been incorporated into this particular secret text. Okay, so that is a quick view of using the text steganography. Different techniques can be used, and we just saw a few, and we can see that it is quite stealth and quite difficult to detect unless you suspect that the message that you retrieve may have some secret message hiding beneath. The next one we'll look at is the image steganography. Take advantages of the limitations of human visual capabilities. Just like the examples that we saw at the very beginning, we have two pictures which looked exactly the same, but one was containing some secret message and the other one was not. One of the most commonly used technique is to use the least significant bit and alter that to encode some secret messages. By changing the least significant bit, the eighth bit of each pixel, we can encode some bit values. And since the 8th bit does not affect the color, does not vary the color significantly, the secret image that we generate will still look very similar to the original message, the image that we had. And typically you will use some lossless compression so that the variations are not very visible. So here's an example of an RGB encoding at the top. Now we want to hide some data which is encoded into 101 3 times. Then we can get the following. So here you see 1, 0, 1, 1, 0, 1, 1, 0, 1. Okay, and I have highlighted the changes that have been made in red. So you can see that it's going to be either 1 or 0, and you have a good chance that it's going to embed into the same code. So if we do this on a large set, maybe we'll approach roughly about 50% of the least significant bit being changed. So we're not actually altering that many bits compared to how many pixel data that we have. Okay, so let's have a look at the demo. So here I have the encoder, the decoder, and the steganography library. And here I have an original image to be used, which is a space. So let's use Python. You do need some libraries, which I installed in Python 3.6. I'll use that. So LSB encoder, I can run this. So it will ask me the same stuff. What image file to be used? Space.png. What secret image file to be named? We'll call it a secret.png. The secret message, the hoverboard does not work on grass. Okay, so it's going to do its thing, and then it says loaded image. It has created a new image, and then it's going to store it, and now image has been saved. So now we have this called secret.png. So let's have a look what's inside. So this is the secret.png. This is the original. Can you see any difference? Maybe make it larger. Secret, original. Yep. So visually, it is very difficult to see any difference to it. So now let's try to retrieve our original message back. So here we're going to use the decoder, LSB decoder. Okay. The secret image is secret.png. Okay. So it's going to extract the pixel information and trying to gather those bits and print out the embedded secret message that we put inside. Okay, the hoverboard does not work on grass. Let's try to do the same, but using the original message, space.png. What do you think we are going to get this time? Have a think. You can post a video too. Okay, so have you guessed? Depending on the code, right? But I didn't do any safeguards. So it's going to try to process it. And when it does, it's going to print out a bunch of gibberish. Because the decoder will still try to get the bit informations. And those bit informations will match back to the ASCII codes. But they're not necessarily alphabets. So we're still going to get some gibberish. But you can always avoid this by putting some safeguards and code checking. So there are various tools available, either as the code ziplets, repositories, or actual applications that does this. So here's a few lists that can get you started with. So we have lots of like messages, images, texts flying around, and many of them will go undetected that are hiding some information. So Steganalysis is a technique to use in order to discover or uncover some of those hidden informations in a given data. This is similar to the cryptanalysis, where attackers can hold various information, either stag only, or it has the known cover or the known message, chosen stag, etc. And all those informations can help trying to analyze the steganography that has been used. So there are many tools that can be used to detect different types of data as well. But you need to know what you're looking for. That is the probably most difficult part of the Steganalysis. It can be an image, it can be a text, or it can be anything else. So there are many other tools in the additional reading items, so please do read. And to make the Steganalysis more difficult, steganography and cryptography are typically used together. So the couple of examples that you saw was to use plain text straight embedded into our normal data, but you can encrypt it first and then embed it. Then when you just uncover the ciphertext from the steganography technique used, it's going to be gibberish, which is similar as the one that we saw with the image steganography before. So this is quite difficult when both of those techniques have been used together. So to retrieve such information, we need to actually apply both Steganalysis and cryptanalysis on a retrieved data. And this obviously adds another layer of complexity. But from a defender's point of view, this can be good for protecting assets from malicious users, and much more difficult to detect malicious activities in that sense. So that concludes the steganography items. The next item is moving target defense.